Good morning and welcome to this little video. I thought I'd make this because I've seen some questions on forums where people are very familiar with the VST SDK, but they're not as familiar with audio units, and they want to know the basics of porting a VST effect over to audio unit, which is actually fairly simple if you know what you're looking at. It gets a little more complicated when you have effects that are more complicated, or if you're talking about custom UIs. But right now I'm just going to show the very basics using the example from the VST 2.4 SDK, which everybody is very familiar with. Since most people seem to be on 2.4, I just thought I would toss this up. And again, this is just the very bare basics, and a lot of this is kind of self-evident, but if you're just starting cold, you might not even know where to look. So let's start with the files over here that we're going to be using. The basics are you have your header and your C++ file here, but with a VST, you're going to be drawing on the VST SDK headers and classes over here. In audio unit, since it's a proprietary format and it's built into the operating system, the only things that you're going to be using that's roughly equivalent are the core audio utility classes over here that you can download from Apple. So let me point out the similarities and differences here. We'll start with the header file. So I hacked together an audio unit example that's similar to the gain example in the VST files, and I tried to make them look as similar as possible. So heading down, this is the header with your basic class, so it's your gain class. Here's the audio unit gain class. You have your constructor that you're calling. With the VST, obviously you're doing your master callback, and with your audio unit, you're just doing a component instance constructor. Your processing in VST, you have your process and your process replacing, your process double replacing. With an audio unit, the default mode is not similar, which is where a lot of people get stuck. The default audio unit process uses a processing kernel, and what it does is it's an end-to-end type of structure, so you have whatever number of inputs to whatever number of outputs, and it generates another kernel for every one, whereas with a VST you have your left and right buses separate that you do your processing, and then you set the number of ins and outs. But there is in your audio unit something that's very similar, which is process buffer lifts, which you can find in your effects base heading right here, and that'll use the format that you're familiar with, where you have access to the left and the right buffers. And you can just drag and drop your VST DSP right into your audio unit file. Then under your the program data, the get and set, and all of the name info here in your VST, that's going to be set somewhere differently in your audio unit, so I will get to that in a little bit. But for right now, we will work with the parameters. So you have your get and your set parameter voids right here in your VST. There are similar functions available in the core audio unit classes right here, with your get parameter info and your set parameter. So you just declare those, and then version info for your VST has your get vendor version function there. In your audio unit, you have your version right there, and that refers to your version header right here. I also enumerated the parameters down here. We only have one, which is your parameter gain, and then set the default, the bounds, the max min, and the default, as well as the name here. Moving on to the C file. For the VST, we are creating our instance right here, and we're returning a new class. For audio units, we have our audio unit component entry. We're drawing on the base, and this is our unit right here. The constructor is fairly similar. So we are drawing on audio effect in VST. In audio unit, we are pulling off the audio unit effect base. Now in the constructor with your VST, you're going to set your number of inputs and outputs. You're also going to set your unique ID for the plugin, which we do not do in a constructor of an audio unit. That goes in a perimeter list file, a plist file, so we will get to that in a bit. You set your default values, of course. The default for our gain in the VST is right here. The default for our audio unit is right here. So we have our global parameter, and we're pulling our set function. The name is gain. Oops. And we're setting that to the default that we set in our list back here at the bottom. So our number of channels that was set in our VST constructor is going to be set down here with the supported number of channels function. There are many modes that you can use. For this one, I chose 3. So we're setting up our array of 3 right here. And we have 1 in, 1 out, 1 in, 2 out, and 2 in, 2 out. So we have mono processing, mono to stereo, and stereo. You can set it to -1, -1 if you want n inputs to n outputs, or you can set any other number of things depending on what your processing function looks like. Scrolling down to the parameter info, in our VST, we're setting all of that in this section here. So going all the way down to gain, that's all going to be set in our parameter info right here in our audio unit. So we have our audio unit base, we're filling in our name, and we defined the name back here in the header file. Sorry if this video skips around. It is trash day here, so I have to keep cutting out noise from the horrendous garbage trucks outside. Anyway, so like I was saying, in the get parameter info here, we set our parameter name, and then we have our min, max, and default. Now for the labels, you have your decibel label here. We have our set of parameters that we're allowed to use right here that you can pull up, and that will label it for you. Sense beats, Boolean, etc., etc. We're using linear gain. You can also set the resolution of the controls here, as well as anything else that you want to do to your controls. Now in our VST, since we have simple controls, when we're calling set parameter, we're just setting it to value. In our audio unit, I have this set up in case we want to do something more elaborate. Really, the important part is that we're just returning set parameter right here. It has your parameter ID, your scope, your element, and all that. If we wanted to do something more elaborate, we would return it right here. And finally, we have our DSP. So in the VST, we have our process replacing function right here. We're going to be processing in floats, 32 floats. So we're setting a pointer to our inputs and outputs, stereo input, stereo output, and we have a cute little while loop right here where we're advancing our input and output, and we're applying the gain to it. Same thing on the audio unit side. So process buffer lifts, we are making floats and pointers to our input and output buffers right here. And then we are doing our processing down here, which you can see is nearly identical. We just have a little while loop. Instead of calling sample frames, we're just calling our in frames to process right there. And the parameter itself, we are calling get parameter and then the name of our parameter, our only parameter, which is gain, and we're setting it to our F gain right here. And there you go. Now, getting into our resources. Like I said, with your VST, you set a lot of the vendor information and copyrights right here programmatically in your C file. In your audio unit, you're going to set all that in your perimeter list and version files. One thing we have to concern ourselves with ahead of time is we had our instance with the VST that just creates it here. With our audio unit, we have our component entry, which we have to define in our exported symbols file. So we have our audio component entry right here, A gain exported symbols. Here's our entry. The factory function is an older function, harkening back to the days of Carbon and 32-bit. I add that for legacy support here. It's not necessary for modern DAWs, although some, like Digital Performer, prefer to have the older version. Since that is the case, if you include a factory function, you need to include a Carbon resource file right here, which I have done. If you are going to be including a Carbon resource file in your project, a couple things you need to know. Under AU base, you're going to need your AU resources resource file. It shows your format here, and then it has all the functions that you need for that. And very important, when you get into your build phases, you're going to go into your build carbon resources, and you want to make sure that your resource file is in there, and you want to make sure that the AU resources is not. When you copy that to your project, it's going to want to stick it into your build carbon resources. Make sure that is not in there. This is the only file, or you will get all kinds of frustrating errors. The VST has our version right here, returning 1000. Our res ID, returning 1000 right here. And our resource file, we have our resource ID, referring back to that. The audio unit type is effect. And our subtypes, we enumerated all of these in our version file, which is going to refer back to that. Now you could define your name, description, and entry point here. It tends to screw up white space, though, and commas and those types of things if you have any of those in the title. So I just tend to type them out to make life easier. And then we have our entry, which is in our exported symbols file again. Now looking back at our version file, you can see that we have defined our subtype, and I will change that to gain. That is your unique 4-digit code for this plugin, and that has to be different, obviously, for each plugin so that it can find it. And then your manufacturer data, which is just my initials and a P afterward for some reason. Now these have to match these, which has to match your perimeter list. So the audio components array is a new function that they added a year or two ago, and that just further defines these things here. So manufacturer, your description, and it's not the end of the world if your description does not match your resource description, but it will throw an error when you run your audio unit validation. It's just a warning. It's not a hard stop error, but it's annoying. And if you're doing this commercially, people will say that they are getting an error every time your audio unit loads, so you want to match that up. Your name. Certain DAWs use the format where you have the manufacturer, a colon, white space, and then the name. And they would not pull up your effect if you did not do it that way. I don't know if there are any DAWs that still do that, but Logic used to do that. So under name, I always use this format. Manufacturer name, colon, space, name. And then we have our subtype here, which we want to match to our version subtype. So there we go. The rest of this data is similar here to the VST version. And since the VST and the audio unit are both bundles, all of this follows a fairly standard format. The identifier that you use to locate it is just your reverse URL, just like it is in the VST. And other than that, there's not too much you need to concern yourself with. Depending on what kind of plugin, you may have more or fewer fields in here. The sandboxing feature in the modern versions of Mac OS is going to require you to use a field here that says that it's sandbox safe, just for example, and other things like that. Now, as far as your frameworks, the old 2.4 version of the VST SDK only requires QuickTime and your Carbon frameworks here. Those we're not using anymore for anything. That's back to the dirty days of 32-bit and Carbon UIs. All we really need is our audio unit, audio toolbox for a couple functions, core audio, core services. These all just have various things that you can search for in the headers to see if you need them or not. Cocoa is the new-ish UI for Apple, replacing Carbon, which has been since replaced by Swift, but that hasn't made its way into audio units yet, as far as I know. But we include that there, and in our prefix, we include Carbon for our legacy support, for the resource file, etc., should we need it. Otherwise, it would just be Cocoa. So there it is. I hope someone found that to be helpful, and if you need any other information or you have specific questions, you can ask me on my blog. Maybe in the future I will do something about porting over UIs. They are different enough that it is a bit odd, and I'm not too fond of the VST UI SDK. So I've barely used it, but it's not too difficult. Just everything is kind of set programmatically, whereas in Xcode with your audio units, you're going to use Interface Builder with a separate bundle that you include in with your audio unit bundle at compile time. So good luck, happy coding, and have fun. Just an addendum here, it occurred to me that I didn't say which parts of the core audio utility classes you are going to be pulling from. There's no simple answer for that. They have a whole lot of useful functions in there, and there's no simple way to know what you're going to use for your particular plugin. So I made this image here of the basic minimal audio unit classes for an audio effect like this, where we just apply the gain. So under our AU public, we have AU base, utility, and other bases. These are just the very basic bases for everything that we used in here. And then public utility, these are the minimal bases that I could find that would not throw errors at compile time. As far as this frameworks, Audio Toolbox, Audio Unit Framework, Core Audio, and Core Services are your minimal. I toss the Accelerate framework in there because I tend to use that quite a bit. It's very efficient and nice for working with vectors and arrays. But if you're going to be including a UI, you will need some of the other ones here, like Core Audio Kit and Coco. There are other bases you can draw on, the instrument bases, etc., etc. If you're going to be making a synth or something like that, you'll have to look into those headers. Without knowing explicitly what each of these headers do by reading through them, and there are hundreds, it's difficult to nail what you need right up front. So I usually just run down the rabbit hole with the headers and include what I think I'm going to need, and then when it tosses an error for some of the includes that I don't have there, I just go and pull other ones into the project. Maybe a more efficient way of doing it rather than trial and error, but there you go.